our presentation. Introduction. This lab is focused on examining and predicting the motion and the change of energy from oscillating spring. Result. Total change of energy oscillates around 0. Here are some of the formulas that were used in the computational coding. Here we have the velocity update formula, the position update formula, the gravitational potential energy formula, the spring potential energy formula, the kinetic energy formula, and total energy formula equals the sum of all these three added together. And here's a video of tracker. And here are snapshots of coding. We have ball's mass at 0.402. So ball's mass and spring constant and relaxed length of spring and G were all given in the pre-lecture videos. And using these and the ball's position vector was obtained from the tracker. It was the very first point where the ball velocity was 0. And using all of these, I found L by doing ball dot position minus spring dot position, and L hat equals L divided by magnitude of L, and S equals magnitude of L minus L naught. And using kinetic energy formula, gravitational potential energy formula, and spring potential energy formula listed in the previous slide, I calculated K, UG, US, and the total energy is just the sum of these three. And I set all four of these as the initial conditions. And using the velocity update formula and the position update formula, I updated the object's velocity and the object's position. And I update the spring by calculating the L, L hat, and S, once again using the same formula that I used previously. And using the three the kinetic energy formula, the gravitational potential energy formula, and spring potential energy formula, I calculated the new K, UG, and US, and E, and I found the energy changes by using the new subtracting the initial. And here are the resulting graphs, where you can see that delta E remained 0. And what does it mean? Questions. So for the first question, yes, the energy principle was satisfied. It shows that the energy was conserved and did not change. And you can see from the previous slide that the delta E remains 0. And for question 2, using the graphs in the tracker, I found it was 1.7 seconds for X and 2.37 seconds for Y. And you can see that the oscillation periods in the Y direction was greater than the X direction. Possible errors. Because we tracked the data by ourselves using tracker, there could have been a minor mistake when tracking data. So the possibility of over-tracking and under-tracking data points. And thank you.